Welcome all to Kinematics class 16, in which we'll discuss about relative velocity of approach. So the relative velocity of approach is the relative velocity with which one particle is moving towards the other along the line joining two particles. Let's see what is the meaning of this. If you are considering a particle 1 which is at rest, and consider that another particle 2 is moving towards 1 with a velocity, let's say 10 meter per second. So we can say that in this situation the relative velocity of approach is nothing but 10. Now if I am just considering another situation, consider that the first particle is moving towards right with a velocity 20 and the second particle is moving towards left with a velocity 10. So over here you can find out, if we are considering 1 is at rest, then 2 is moving towards 1 with a velocity that is equal to 30. So in this situation we'll write the value of relative velocity of approach is nothing but 30. Now if you are just considering a situation something like this, if 1 is moving along this direction with a velocity 20 and let's say this is making an angle 60 degree with respect to the line joining particle 1 and 2, and assume that the second particle is moving along this direction with a velocity 10 and it is making an angle 60 degree with respect to this. So we can find out what about the component of velocity along the line joining first particle and second particle. This we can take it as 20 cos 60, that we can take it as 10, and this we can take it as 10 cos 60, that we can take it as nothing but 5. So we need to just observe the velocities along the line joining them. So you can find out along the line joining them first and second particle, the relative velocity is 10 minus 5, that is equal to nothing but 15. So we can say that the relative velocity is nothing but 15 meter per second. So in general we'll represent it something like this. If the component of velocity of first particle along the line joining first particle and second particle is v1, and the component of velocity of second particle along the line joining the first particle is v2. So we can say that their relative velocity of approach is nothing but v1 vector minus v2 vector, or v2 vector minus v1 vector. Now we'll take an example for this, what type of question may come related to this relative velocity of approach. Just consider an equilateral triangle and a particle A is starting from point A and particle B is starting from point B and another particle is starting from point C. Now just remember, this first particle is always moving towards B and this second particle is always moving towards C and the third particle is always moving towards 1. So let's say the first particle is moving with always moving with a speed, let's say that is v, and second particle is also moving with the speed v, and third particle is also moving with the speed v. But 1 is always aiming towards 2, 2 is always aiming towards 3, and 3 is always moving towards 1. So at this instant we can say that 1 is moving towards right because A is on the right, 2 is on the right side. So in a small duration of time A may reach somewhere over here, or the first particle may reach over here. Then the second particle reach over here and the third particle may reach over here. Now we can just consider that now second particle is over here, so the first particle is always aiming towards the second particle. So this is going to move along this direction. So after some time first particle will reach over here, but the second particle is always aiming towards the first particle, so it may reach over here. And the third particle is always aiming towards the first particle. So we can say that at this instant the direction of motion of third particle will be something like this. So it may move by some distance over here. Again this thing is going to continue. So now this is moving towards 2, so it may move along this direction, and 2 is moving towards the instantaneous position of 3, and 3 is moving towards the instantaneous position of 1. Again this thing is going to continue. This is going to move along this direction, so it may reach over here. This is going to move along this direction, and this is going to move along this direction. So it may reach over here, it may be over here, or it may be along a point over here. Again this thing is going to continue. This is moving towards this, and this is going to moving towards this, and this is going to move towards this. So like that the situation will continue. So if you are further drawing the situation, so we can observe that basically this particle 1 is going to move through a path something like this, and after some times it will reach at the centroid, and particle 2 is going to move through a path something like this and it reach the centroid, and the particle 4 is going to move through a particle 3 is going to move through a path something like this, and after some times it will meet the centroid. So collision of 3 particles is going to happening at the centroid. Now in question they will ask to find out what about the value of time taken for its collision. So it may be difficult to observe the situation something like this because 3 particles are moving, but as we know that there is a collision is going to happening between these 2 particles, so we can easily calculate it by using the concept of relative velocity of approach. Now again, if you are observing the situation, the first particle is moving towards right with a velocity v, and the second particle is going to move with a velocity v along this direction. So we can just find out what about the relative velocity of approach. So as it is an equilateral triangle, this component we can take it as nothing but 60 degree. So this component of velocity is going to be nothing but v divided by 2. Now we can just consider only the particle 1 and the particle 2, and let's say the distance between them is nothing but L. So velocity of first particle is v and velocity of second particle is nothing but v divided by 2. So we can find out what about their relative velocity of approach. So with respect to first particle, we can say that second particle is going to move with a velocity v minus of v by 2, that is v plus v by 2, that is 3v divided by 2. And so the initial distance between them was L. Now when they collide, the distance between them, relative distance between them becomes equal to 0. So we can find out the value of time taken for collision is relative displacement divided by relative velocity, or you can write time will be equal to 2L divided by 3v. So this one is a way we'll solve such type of questions. Hope so that you understood whatever things we discussed in this class. If you are having any doubt, please contact. Thank you.